Grateful for the opportunity to present some early research on AI for aging and longevity. And first, I would like to point you to the Biomarkers of Aging Consortium. So they are doing conferences, and there's a competition also. And I've been involved in 2 of their papers on defining biomarkers of aging and also on validating biomarkers of aging. And obviously biomarkers of aging are really useful to predict future health and survival, and meaning better values give you an indication that you have longer health and survival. And the other major application is to predict suitable interventions. So you want to match your biomarker values to intervention data where people with similar values actually benefited from that intervention. And here's an example actually of a query for a specific intervention, quercetin. Should I take 500 milligrams of quercetin every day with a personal profile? That's not me. And we asked a large language model for a response. And here you can see the start of the response. It's Claude Opus. And it considers those simple biomarkers, including also overweight, atrial fibrillation. And you got a summary. And the question then is, what is a good advice? How can you find out the quality of such an evaluation for an intervention? And for any advice, actually not just by AI, but also by humans, we are expecting correctness, of course. And then also usefulness, comprehensiveness, interpretability in a concise manner. And there are some consequences. And of course, if you want correctness, you want to, for example, for a human, you want to turn to an expert. In a way, it's benchmarking. And also for AI, there's benchmarking for correctness. And you also want to check your input data quality. Otherwise, you've got garbage in, garbage out. Essentially, you want to check everything, also the reasoning, if you have got a large language model, and so on. And for comprehensiveness, there's certainly an advantage of AI. So you can use, for example, retrieval augmented generation to search the internet, and then the AI assembles information and its evaluation or its recommendation based on those data. Could use knowledge graphs. You can do a kind of meta-analysis. And there's problems, as most of you know, with interpretability or closely related explainability. There's an entire research field on XAI, explainable AI. Those are 3 very general quality criteria. Then more specific for intervention advice, certainly there you want to consider causality, meaning, for example, taking data from randomized controlled trials. You want to consider side effects and toxicity, maybe consider adverse outcome pathways, and also more interdisciplinary evidence, including social factors, feasibility, sustainability, and also consider standards, reporting standards for such evaluations, and so on. And lastly, for longevity intervention advice, we suggest that you want to consider large-scale longitudinal human data, like UK Biobank, NHANES. And also you want to consider known aging-associated processes, the hallmarks or pillars of aging. And then the question now is, do such quality criteria help? And how can they help? So actually, yes, they do. And here's the example I just presented a few minutes ago, asking for quercetin, whether that's a suitable intervention. And if you then add those requirements that are listed to the prompt, actually you get a much, much better result. The model is then not just talking about some dose and evidence regarding, for example, immunity, since there was also a slow vaccination response as part of those simple biomarkers. But it then actually starts talking about, that's in green here, about the possibility that quercetin may interact with medication for atrial fibrillation. Since atrial fibrillation is also listed as one of those, as a kind of disease biomarker. And I think this is quite intelligent. So here we have got some artificial intelligence. And it does it only, we tested that several times, it does it only when you list those requirements, which include toxicity and side effects. But it's also okay, but this is our best example so far. But we did a very systematic analysis also. Here's in particular for a related query, namely, should I take rapamycin? Also with some biomarkers, like I'm 50-year-old, I've got maybe not a good immune response, overweight, some things like that. And that's what Anton Kulada did a month ago. We looked at how another language model from another family actually evaluates the result from this first language model, which is Claude in the beginning. So it's Claude evaluated by GPT-4 and GPT-4 evaluated by Claude. And there were all those 8 quality criteria. And you can see in the first row, there's Claude Opus without requirements. Then it's with requirements. And there's one green mark where it's actually an improvement based on the assessment of GPT-4. That's for holistic evidence, including toxicity and side effects. And there were many more improvements if, in case of GPT-4 Turbo evaluated by Claude Opus. And this is a beginning. We keep working on that. We have a manuscript outlining those requirements. And this is joint work also with people in Heidelberg at Julio Saiz Rodriguez lab, Sebastian Lobentanzer, and with Brian Kennedy, Mats Unfried, who most of you know, or all of you know, I guess. And then now coming back a bit to things I presented last year. That was a strawberry study. It's now been published in Aging Biology. The idea was over a couple of weeks, 10 weeks, in 160 healthy elderly people to look at the effects of high amounts of polyphenols in the diet. And essentially, at the very end, in group 5, on the last day, they had to eat 200 grams of dried strawberries, which is about maybe 2 to 3 kilograms of fresh strawberries, carrots, and olive oil. And the pretty exciting thing we found is an upregulation of apoptotic signaling in this last group just before the blood draw, when the day before they ate all those strawberries. And they did this just on 3 single days over the entire study. You don't want to do that every day. It's probably too much of a challenge. It's also not needed if apoptosis actually means senolysis. So the hypothesis is that we were able to kill senescent cells that way, senescent immune cells. We got apoptotic signaling up. We also got Judicampiesis, oxylipine, senolysis marker up, but not significantly, unfortunately. And maybe you could attribute this effect to fisetin. Fisetin is known to kill senescent cells. It's supposedly in strawberries, but we looked hard. We did not find any fisetin in our strawberries. But we found quercetin, which is closely related. There's just one OH group, which is allocated to a different position in the molecule. And quercetin is also known to actually induce apoptosis in vitro and in vivo, so it made sense. And the idea is nutrition mimetics of senolysis. And also, last time I mentioned briefly nutrition mimetics for partial to transient reprogramming. That's even more of a challenge. And of course, you cannot reprogram your stomach or anything like that by just eating something. But maybe you can get a little close. It could be rejuvenating. So last time I presented results for Paranate and Repsox, which is a 2-compound cocktail which does some rejuvenation effects in cells at least. The 2C formula. And for Rhapsods, at that time, Claude 2 found nutritional mimetics, including quercetin, and food mimetics, including berries. I was kind of happy about that. And now just a glimpse of the current work. We're working now on AI advice, on nutrition mimetics for at least having some partial reprogramming. And we asked the model for epigenetic change induced by Parnate. And among other things, it came up with suppression of the epithelial mesenchymal transition via epigenetic changes. And interestingly, looking for natural supplements who do something similar. It went for dalotadechin gallate, which you find in green tea. And I'm almost at the end. So one big message is, of course, AI must add value to human judgment. It should be much better in the end. We have got some criteria I listed. Maybe not so obvious causality, longitudinal data. This could mean that you want to use knowledge graphs and also visualization. And we've now got two major projects in our group where we are, on the one hand, developing a health and productivity advisory tool based on large language model advice, and we are testing intervention analytics. This is my last slide, essentially. We are looking for business-to-business customers now for a company to start in next year. We have got ministry funding to prepare a startup in this intervention analytics, want to use AI and classical bioinformatics, evaluate, compare, rank, and repurpose interventions, want to focus especially on safety and side effects. And any intervention goes. Also, we can compare interventions from partial reprogramming to nutrition. We just need sufficient biomarker data. Yeah, that's the last slide. So there will be a longevity week in Rostock, early October. And I invite you to Rostock. Rostock is close to Berlin. Most of you know Berlin. If you're taking the highway from Berlin to Rostock, maybe you'll see one of those road signs. Willkommen im Land zum Lang und gesund Leben. The state of a long and healthy life. I propose to add the long and healthy to that, and maybe it's done until October. Yeah, and I thank the funders and everybody who helped us that, and I thank you for your attention.
Thanks, George.